Hi everyone, just wanted to take a moment to talk a little bit about how to solve systems of linear and quadratic equations. So this is kind of bringing us back to the world of solving systems of equations, right? We would solve by graphing, we would solve by elimination, we would solve by substitution. But before they were just lines, right? Which made things a little bit simpler. But now we are going to have one where we have a parabola and we will have one that is a line. So ultimately, that results in a slightly different approach. We still can do the same things, right? We still can use graphing, we can still use elimination, we can still use substitution, but we do kind of then have to go a little bit further. All right. So ultimately, what we're going to be doing is we're going to be solving equations involving both linear and quadratic equations. And we're going to talk about kind of the relationship between the different scenarios, right? So back when we were dealing with systems of equations, essentially all we had was you just had two or more equations that you're kind of solving at the same time, and you were looking for the point of intersection, right? So how are they kind of related? Well, if you were to graph it, there's still going to be a point of intersection, right? And much like when we were solving parabolas just in general, right, where you were trying to find the x-intercepts, we could end up with 0, 1, or 2 solutions, all right? So it's going to be where the line and the parabola intersect, all right? So we could have no solution. And that kind of looks, there's a lot of different ways you can make that work. A lot of times you kind of will have like a horizontal line, just, below or above the parabola, depending on which way it's opening up. You could kind of have, a line that is never going to cross, that is diagonal, kind of looking like this. You do have to be careful with these because, because parabolas do increase up forever. You have to be certain that it's never going to like cross forever at some point. But if it doesn't cross down here, it's not going to cross up there. Right? That would be like before when we had parallel lines, we had no solution. We could have one solution, all right? So we could have the line crosses the parabola only once. That a lot of the times will kind of happen at the vertex, but it doesn't have to. It doesn't have to happen just at the vertex. A lot of the times it's really kind of, if it's not at the vertex, it's going to be where like it'll cross one side and then kind of be increasing at a rate that the other side will never touch it. Kind of like this one over here, right? This one actually looks like it's tangent to it. Like it just kind of hits it and keeps going. And then you have the other situation where there's two. This one I think is probably the most obvious to think of, right? If you will, it kind of goes through the middle. It crosses twice. It comes in, comes out, stuff like that. So do kind of keep that in mind when you're solving these, so that you can have 3 different scenarios. Also, as illustrated, you can still just graph these and find the points of intersection. So graphing the system of equations will still work. All right, so it will still work, right? So if I asked you, how many solutions does this have? Y equals x and y equals x squared. Well, what can we do? Let's go to Desmos real quick, because we know kind of, if we graph it, we can find that point of intersection. Y equals x squared, right? So you can see here we have 2 situations where this works. We have 0, 0, which, that makes sense. 0 is equal to 0 and 0 is equal to 0. And we have 1, 1, which still makes sense, right? So we do have two solutions to this. Okay. Now, you didn't just need to graph it. There's a couple other ways that you could have gone about solving this. All right. So just kind of taking a quick look back at this. If we graph it, we find it has 2 points of intersection. Now, I could have used any of the other methods, right? I could have done elimination. Okay, I'm going to make, if I wanted to do elimination, I could make this one negative and make this one negative, right? Add them together. There's negative y plus y, that's 0. Negative x plus x squared is x squared minus x, right? And what do we have here? We have just a quadratic equation that you know how to solve. 0 is equal to, I'm going to factor the x out. I'm going to get x minus 1. So now I have two different things. I can set equal to 0. So x equals 0, or x minus 1 equals 0. So x would equal 1. Right? And there's my two solutions, 0 and 1 again. Alternatively, I could have substituted. I have y equals x and y equals x squared. I could have substituted, we know y equals x, so whoop, substitute that right there. I get x is equal to x squared. Subtract it, I would have gotten 0 equals x squared minus x again, right? So you could have done any of those methods, and whatever you feel most comfortable with, I encourage you to use. Again, there will, as always, be certain situations where some are easier than others, but it's ultimately your choice. Sorry. All right, so let's go about solving some of these. So what is the solution to this equation? If I were to rewrite this as a system of equations, right, what would this be? I essentially have just done substitution for this, right? So I have y would equal x squared plus 1, right, here's part of it, and y equals x plus 3. This might even make things a little bit easier. Right, we've seen quadratic equations that I've given you in the past that look very similar to this. And I told you, well, you have to bring everything to one side, and then you have to factor it or whatever. Well, now you could just set it up this way and graph, right? So x squared plus 1 and x plus 3. Plus 3, x squared plus 1, right? And I would have gotten negative 1 and 2. Now, if I went through the other process, this is essentially substitution. So I could have then just brought everything over to one side. I would have had x squared minus x minus 2 is equal to 0. I then could have factored that. I would have had x minus 2, x plus 1 equals 0. So it would have ended up with x equals 2 and x equals negative 1, which is exactly what we just saw. Right? Negative 1, 2. All right? So again, it does not matter which method you use to solve this. And also do think about this. When you're essentially setting them equal to each other, you're almost like kind of creating a new quadratic parabola where the solutions are the points of intersection, right? So because if I graph, let me do this one, equals x squared minus 2x minus 1. Nope. There we go. Right? You can see here, this parabola has 2, 0, and negative 1, 0, which is the same as right here, my point of intersection of negative 1. There we have it, right? You can almost see that like we've kind of created this new parabola to illustrate my solutions. All right, so on this one over here, oh, that's annoying. I don't want to do that. This is one where I could, again, I'm going to graph this one. So I have y equals 5 minus 0.5x squared, and I have y is equal to negative 0.5x plus 2. Okay, so let's graph those. 0.5x plus 2, 5 minus 0.5, that plus 1. Rid of that, it's adding too much. So I have now 2 points of intersection at negative 3 and 2, which actually indicates to me this would have been not terrible if I had gone through the process of factoring it. All right, so you can always rewrite these as two separate quadratic functions and graph them. All right, similarly, first of all, that also shows you the relationship between the graphing and the substitution method, right? Because this is essentially the substitution method, and then I could have solved it by doing this. You could have also, as I said, done the elimination method. All right. So to do the elimination method, what you're going to do is you're going to multiply both sides of one of them by a negative, and then you're going to combine. Okay. So let's add these together. Y minus y is 0. X squared, there's no x squared down here, so I'm just going to leave it alone. Do not try and combine an x squared with an x. You still have to combine like terms. Negative 6x minus 2x. It's negative 8x. 8 minus a minus 4 is plus 4, so 8 plus 4 is plus 12. Okay? So now what am I going to do? I'm going to find factors. Well, at this point, this is just a quadratic equation, right? So you could factor it, you could graph it, you could complete the square, you could use the quadratic formula, whatever method you see fit. This one is nicely factorable. This is x minus 4. Oh, wait a minute. I think is this factorable? Yes. X minus, it's not 4. Silly me. Okay, so I ended up with 0 is equal to x squared minus 8x plus 12. I need factors of 12 that add up to negative 8. They're both negative. So I need x minus 2, x minus 6 is equal to 0. So I would get x equals 2 and 6. All right. So ultimately, all we're going to be doing is we're just going to be combining them and then solving the same way we would have always solved. All right. Let's do one more for good measure. Let's do this one. Make it negative, make it negative, make it positive, right? Change the sign, add them together. 0, negative x squared, negative x plus 6. Oh, I don't like that. All right, so now we're in a situation where I have a negative. I don't want to deal with that. I don't like dealing with negatives up front. I'm going to move everything to the other side. So I get x squared plus x minus 6. All I did was I just brought it to the other side. That doesn't make a difference, okay? That's just the equivalent of me making this positive, or changing this one as opposed to this one. All right, and I'm only doing that because I don't like a negative x squared, because then I have to factor using like AC, where a is not 1. It's negative 1, which does make a difference. Okay, so now I'm in this situation, so I need, what is this? Plus 3 x minus 2 equals 0. So I'm going to then solve. I get x equals negative 3 and 2. And there you have it. So this is essentially what we're going to do each time. You are going to either rewrite them by substituting and then solving for 0, and then, using whatever method you see fit to solve the quadratic equation. You could graph them. Or you can, again, use elimination. Any of the above will work, but they will all come up with the same solutions. All right. So let me know if you have any questions, and have a great day.